Welcome to our next video on adding and subtracting rational expressions. Now, two things I want you to look at closely before we really start to actually add number one. First of all, this might be the only time where adding and subtracting is actually a little bit more difficult than multiplying and dividing, and you might see why if you look closely at number one, because the second thing I want you to have your attention brought to is the fact that this might not look like what you've been talking about as rational expressions. I did this for a reason. Just like adding regular fractions as you see here, when you add a rational expression like you see in number 2, you need a common denominator. So always remember, when you add or subtract any kind of fraction, you need a common denominator. So when I look at this, when I think about a common denominator, hopefully the term LCM comes into mind. Because if I find the LCM of 7 and 3, that would give me a number that both 7 and 3 go into. In other words, a number 7 and 3 both have in common, and it will be the smallest one. That's why the L is there, least common multiple. So either use your calculator, or I know many of you are smart enough, the least common multiple, the smallest number both 7 and 3 go into, would be 21. Which means I need to turn this 5 over 7 into some number over 21. In order to do so, it would be like multiplying this by a value of 1. Because you know in math, if I multiply by 1, it doesn't change the value of the problem. And so if I have a 5 over 7, multiplying by 1, turning that 7 into a 21, if I multiply by 3, that would work. Well here, if I want to multiply by 1, 3 over 3 is the same thing as 1, because anything divided by itself is just 1. And so that means 5 over 7 is the same thing as 15 over 21. And then I can do a similar thing for 2 over 3, and I would find out what do I need to multiply the 2 over 3 by to turn that into a 21. Well, same idea, 3 times 7, and so I would want to multiply by 7 over 7 to get a 14 over 21, and then I could add my two fractions. My fractions 15 over 21 plus 14 over 21, which, remember, when you add fractions, the denominator stays 29 over 21, which can't be reduced, and so that's my final answer. So now let's look at number 2, because number 2 is more of the flavor we've been talking about in class. Now, what's nice about number 2 is these rational expressions already have a common denominator, so I'm ready to add. 5 plus 2 is 7, and x plus x, well, remember, don't get confused. When the denominators are the same, you just rewrite it. And so that's a 7 over x, which you certainly can't reduce, and it was that easy. Adding rational expressions, so long as you have a common denominator, not too bad. 7 over x. But let's move on to some other ones where we'll be subtracting, and they might not necessarily have a common denominator. For example, looking at number 3 here, they don't have a common denominator, and I'm subtracting. That's a double whammy right there. So first thing I would recommend is let's make this plus a negative. So essentially I'm adding anyway. And now it'll look more of something like we've been using in class. I got a negative number, which subtracting and adding a negative are the same thing anyways. But now when you multiply this x to get a common denominator of a 2x, I'll just have to keep in mind this is a negative 4, no longer a positive 4. So again, I need to turn that x into a 2x. So, in order to do so, I'm going to have to multiply by 2. X times 2 is 2x. So, multiply by 2 over 2, negative 4 times 2 is a negative 8. And now, that would leave me with 3 over 2x plus a negative 8 over 2x. Add across, denominator stays the same. 3 plus a negative 8 is a negative 5 over 2x. I can't reduce it, so that's my final answer. here's where they start to get a little bit trickier. I've got a lot going on here. I would recommend again to make this plus a negative x, just so that I don't have to worry about any minus signs here and having to distribute, especially if this was a quantity. Now it's only one thing, but that would make this somewhat tricky. What's nice is, again, I have common denominators. So I can just add right across now. Put my fraction bar and my denominator stays the same. And now add like terms. X minus x, well, they cancel, which means I just have a 3. And I can't reduce or simplify this, and you wouldn't necessarily need to distribute that too. In fact, if we did and we look at these two numbers, both are acceptable, but when we look at the next lesson, anyone who's going to stay tuned for the video lesson on multiplying and dividing, you'll realize I would rather have factors than terms. These are two terms, and here I have two factors because I'm multiplying those two things together. I would much rather have mine in factored form because it will help when I multiply and divide. Again, both would be acceptable, but let's keep them in factored form when possible. Like I said, if you want to, join us on our next lesson on multiplying and dividing rational expressions.